How are you all doing? You are welcome to the session, and today we'll be just going through Flare um, with regard to the Nile Hackathon, understanding what Flare is, and getting us started on how to build on Flare. All right, just a moment. Who just joined? Let me check out. Oh, that's me. I'll share it. So um, excuse me. So Flare is a blockchain for data, just like this page says. And what that means is that it provides data on chain from the internet and also from other smart contracts from different blockchains. And you can use that data within your decentralized applications, do some different kinds of things and amazing work. So I'm just going to go through this presentation and have us understand Flare in a little bit more detail. So Flare is EVM compatible. That's very important to put across. So for anyone that is going to be building on Flare during the Nile Hackathon, if you already are familiar with Solidity, it is definitely exactly the same thing. All you have to do is just change the configurations of the chain that you'll be deploying on. And you have your application, your decentralized application, your smart contract deployed on Flare. The only difference that makes Flare different from other chains is that it has an enshrined data oracles. These are the oracles that provide the data into your smart contracts, and we're going to be getting price data of one of the most popular assets using one of the enshrined data oracles of Flare. So we'll be building a simple smart contract, and these are some of the resources that we're going to need for us to be able to complete this task. Everything we need is definitely on the Flare Developer Hub. We'll be looking at it, and just like every other wallet, that every other EVM compatible chain, you would need maybe a browser wallet for you to be able to deploy, or you could deploy with offline smart contracts frameworks like Hardhat and Foundry or Brownie. But for today, we'll be using MetaMask, a web-based wallet that you can use to deploy your smart contracts, and using also a cloud IDE called Remix. So you can get your tokens from the Flare faucet. We'll be looking at it. And we'll be deploying on the Flare testnet. It's called Coston 2. So essentially, we're going to be interacting with one of the most, one of the two data oracles of Flare called FTSO. So that provides price data into your smart contracts. Rather than you using a dedicated oracle like Chainlink, you now will be using an enshrined data oracle within the Flare ecosystem itself. So that has a number of advantages. I'll be pointing out some of them as we go on. So we'll be catching the price feed of either get Bitcoin or Flare, anything that you choose. So there's a number of other tools that you could use to build complete applications on the Flare blockchain. Wallet SDKs are supposed to help you um, uh, enable connections between your applications and the web browser wallets for for perhaps any application that you'll be building, but also tools like Turnkey can enable you build embedded wallets. Actually, Turnkey and Web3 Auth are really good for that, to enable you build embedded wallets in your application, so that your users don't need to have experience with using actual web wallets. All they have to do is just have the seamless experience of using an application in Web 2, but in the background, it's a Web3 application with embedded wallets. So also, cross-chain communication is enabled through bridges like Layer 0. So Layer 0 is a bridging infrastructure. Under the hood, it has a number of bridging mechanisms. You can communicate with Chainlink, CCIP, you can communicate with Wormhole, and all the other bridging mechanisms that you might already know, they're enabled and shrouded under layer 0. So with Flare, you can now do cross-chain communication through layer 0. And also these others. Then indexers, these just get information on the Flare blockchain, and then you can use it perhaps on your front end in your application. So they're just data indexers. Things like, so there's the graph, if some of you are familiar with the graph. Gold Sky does a similar thing. It gets data, only that the mechanism is different. It gets data from a blockchain and then provides it for you off-chain in your application. So that's also a tool that you could use. And core protocols, of course. So today we'll be looking at FTSO, but there's also FDC. So what FDC does is provides data from other smart contracts and also from APIs of the internet. And then F assets. So F assets is one of the features of Flare that enables it to scale non-smart contract blockchains and bring them, introduce DeFi to those blockchains. So through F assets, we have introducing DeFi to Bitcoin, introducing DeFi to Doji and XRP. So right now, I think XRP is the most mature project. There is already a project that is utilizing F assets for XRP to enable yield. I think it's called Fireflies. Yeah. So I'll look it up, but that's what F assets is designed for. FDC for bringing data from other smart contracts, other blockchains, from the internet in general. You might want to get data of perhaps the results of a football match, so you'd be able to do that through FDC. And FTSO is exclusively for price data. So if you want to find out the current price of Bitcoin, the current price of Flare, denominated in US dollars or USDC, you can do that with FTSO. So yeah, that's what we're going to be doing, front-end integration. We might not really have enough time to do this, but we have a bootcamp coming up, and I'll be talking a little bit more about it close to the end of the session. So we'll be able to learn some of these things during the bootcamp. It's a rather short hour, so I will talk about that. Now, I think let's just jump into it and see how we can actually build tools that utilize one of the most commonly used Flare protocol, which is FTSO. So you can always get all the information you need. For instance, if you're going to be building, you need testnet tokens, you need configuration of the chain that you're going to be building on. So we have the Flare developer resources here. You can come here and get everything that you need to build. So let me share this perhaps. For those of you that are building applications that require information, but particularly price data, you might consider deploying on Flare. There is a bounty for the hackathon. I'll talk about it later. So from right here, I'll be able to get everything that I need. So we're going to be deploying on Flare Custom 2, which is Flare testnet. And yes, if there's anyone with a question, you could probably raise a hand. I'll be able to help as my screen loads. So this is the developer hub, and it has almost every resource that you'll need. So there's information from Flare mainnet, about Flare mainnet if perhaps you're going to be building and deploying on Flare mainnet. And there's also information here about Flare testnet custom too. So the RPC we'll need is here, the chain ID is there, the block explorer is there, and the most important right now that I want us to actually look at is the faucet, because we'll need testnet tokens to deploy our smart contracts. So when I click on that link, I think I should actually share that link in the chat, but I'll also share this in the forum where we'll be communicating as developers. Yes, Vian, you have access to the video. So yeah, that's my testnet loading. I'm going to put it in in the browser where I'll be building. So I'll be building my smart contract right here, and let me put it right here so that I can access the wallet. Okay, so all EVM compatible chains compile Solidity code. So Flare is also EVM compatible, only that it's a layer 1. So that means it's an infrastructure of its own, physical infrastructure of its own. It might have the same features as Ethereum in the sense that it compiles the same language, but it's essentially a different blockchain. Well, I don't know why this is not showing. Okay, as that loads, perhaps I could show you something. Oh, my network is slowing, but that's okay. Should be able to get in order. Just a moment. Okay, so this is the faucet. I wanted to open it from this side so you can all see how I can obtain the testnet tokens. So I already had a bit of testnet tokens on my account, but I'm going to get more so that you can, just to demonstrate how you can actually get your testnet tokens to deploy on Flare Custom 2. Okay, so this is the Flare faucet. All right, so as I attempt to load there, let me open FTSO. So in the developer hub, you should also be able to see information about these different protocols and how you can use them to build, how you can use these resources to build using these protocols. So we have FTSO, we have FDC, Flare Data Connector, and Flare and F Assets. So I've talked about them briefly, but particularly we're going to be building with this one, Flare Time Series Oracle, the one that provides price data for different assets. I really hope this works. Okay, so right here you should be able to see everything you need to build with FTSO, and we won't be reading through it. If you're interested in getting to have a depth of understanding on how Flare Time Series Oracle works, you can come to this page on the Developer Hub and be able to find out everything that you need to find out. So we're going to be trying to interact with FTSO using a sample smart contract. And I'm going to build right here. Let me open Remix. So Remix is a cloud IDE for anyone that is not familiar with it. So this is where you write your smart contracts. Solidity smart contracts to be specific. And if you're choosing to build on Flare during this hackathon, this is a tool you might need to actually write your smart contract. Or also if you're familiar with VS Code and you would love to try out the offline IDEs, yeah, we might have a one-on-one with you, although because the hackathon is having a very short time to its end, I prefer to use this option because it's much faster. So to create a new file, you simply come to the very top here and click on this create new file symbol. Let's find the price of Bitcoin, perhaps. I'm going to call it Bitcoin price. Bitcoin price. So Bitcoin is a crypto asset, and we're going to be writing a smart contract that fetches the data, fetches the price of Bitcoin, the current price of Bitcoin. And writing a Solidity smart contracts, these are preliminaries. The license under which you're writing the smart contract in terms of its reusability, licensing its reusability, and then the Solidity compiler version that you want to use to write your smart contract. So after that, type the keyword contract. So I'm going to call it BTC price. price, put it as script. Everything is inside a script block. So now, for us to access FTSO, there's a number of components that we need. Pre-built smart contracts that we're going to be using for us to access FTSO, and two of them are right here in our sample smart contract. So every time you see a reference like this, that means this information is actually on the npm registry. These components are the npm registry, so I'm just going to copy it. But you can always find this in the npm registry if you're interested in maybe seeing what other features exist within these different folders. Could actually give it a look and see if we can actually find this interface. So when you're importing an interface, just like in JavaScript perhaps, you start with the keyword import, and then in the brackets to put the name of the interface that I'm going to be importing, importing it from this location. But what is its name? Everything is right here. I'm just redoing it so that I can explain it and you understand it when you're doing it. So the test FTSO v2 interface. So what an interface is, just like in other languages, it's just a blueprint of an implementation. So in this case, it's a blueprint of the implementation of a smart contract. So that means it represents, it has a reference of the functions that are on a certain smart contract, and every time you call those methods through this interface, the execution is done on the smart contract that you're going to connect to this interface. So it's a blueprint, but for it to be able to serve its purpose, which is to enable you to call the correct functions on a specific smart contract, it has to be connected with a contract address, and that's what we're going to do. And yeah, we'll be able to access FTSO and then specifically get the price of Bitcoin. So I've imported the interface. Now I need to import the contract registry. So all the smart contracts that give you access to these protocols are stored in a certain registry called the contract registry, and you can get that as well from right here. These links are there in the test smart contract here. You can always come back to it and take a look at it and copy them from there. You don't have to get that in your head, like master it in your head. So I want to be importing it from that location, and it's called the contract registry. So this is where the smart contracts that give us access to these protocols are. And let me save it right here. So I'll be importing it from there. So now that I have those two pieces, those two contracts, it's now possible for me to interact with FTSO. And how do I do that? So inside my contract, why is it showing an error? Expected identifier. Okay, let's just go ahead. Perhaps I'll figure it out as we go on. So one thing I want to mention is that every single price data, every single asset price data that you pick has a very specific feed, very specific. It looks like a contract address itself, but it's a byte 21 variable. So you can get all the price feed data points right here. Let me open it from here. So every specific asset has a very specific price feed. And you can get them from right here. So I want to get the one for Bitcoin against USD. Every feed has a specific ID, and Down here, you can see the specific IDs for the price feeds that you can get. So this is Flare against USD. It's actually encoded, but I don't want to go into the details of explaining how it's encoded and what this byte value represents. But this is the one that I want, BTC against USD, and I just copy this. So with this, I should be able to capture the current price of Bitcoin denominated in USD, and I'm going to paste it here as a state variable. So it's bytes 21, and I want it to be public, so I want to be able to view it after deploying the contract, and I'm going to call it BTC USD feed ID. Great, so with that I should be able to get the price of BTC, but how do I connect that price feed to FTSO? Now that's exactly what we're going to be doing. So I'm going to create a function because all executions in Solidity happen inside functions. I'm going to create a view function. So a view function simply gets information from state and does some computations within itself and then returns results based on the computations that it has done. So I'm going to call it a BTC price, and I want it to be external. I don't need it for anything inside the contract itself. So visibility modifiers specify the scope of visibility of a function, but we won't go into details of that. So external view and returns. So I'm going to put very specific data types here, but I'll explain what I'm doing when we start returning the results. This is an int 8, and I think it's a uint64. Now inside this function is where I'm going to write my code that is responsible for returning those results, returning the price of Bitcoin. So first of all, I need to connect this interface to the contract address of FTSO, and I'll keep referring to this code so that we can all know where to catch it and understand what is actually happening. So you see this method that I call on the contract registry, get test FTSO v2. This one gets us the instance of the contract of FTSO. So I'm just going to copy it and put it right here. So what this does for us is that now we have an instance of FTSO and we can interact with it now. Okay, let's just go ahead, we'll figure it out. All right, so the next thing that we need is now to call this method get feed by ID on the instance of Flare time series oracle that we created and pass in the feed ID of the asset that we want to get, whose price we want to get. And that is all that you need. Basically, that's all that you need for you to be able to capture the price of a specific asset. So this isn't the asset ID that we declared. The asset ID we declared is this one, the feed ID rather. So when I paste it here, unless there's another issue, it should be able to. Okay, oh, BTC price, yeah. I declare the contract and the function with exactly the same name. That's not acceptable. So I'll just put a space in between. Let me see what's the other issue. Okay, let me just change this to a complete word Bitcoin price. So this should already allow us to get the price of Bitcoin if we deploy this on the correct chain. So I'm going to explain um, these three values returned in a tuple in just a moment. Okay, I think that's a warning. It should let me work. Oh, the contract is still compiling, but this is it. So what happens is this method returns three values, and those three values are in this specific order. This represents the actual price of the asset. Then this represents the number of decimals on the value. So the thing with Solidity is that it does not work with decimal numbers, like directly having decimal values, but there is a mechanism that we might not be able to go through right now that allows it to get the correct values of things by increasing the number of decimals that a value has, so that you can have very specific um, very specific values without using decimals. So this represents the number of decimals that that the asset has, the asset price has, and then this represents the timestamp at which this data was delivered. So we need now to deploy this on Flare Custom 2 to be able to catch this price, because the contracts that enable those protocols to operate are deployed on Flare networks. So I have to deploy on a Flare network. So in this case, I want to deploy on Flare Custom 2. I hope my wallets will be able to work now, because this is the time when I really need them. Okay, so this part here is the Solidity compiler, and it's recommended that you actually work with a London version of the Solidity compiler to be able to compile this code correctly. So we're going to go to deploy and deploy on custom 2. So I have to connect my wallet to this application Remix. Are there any questions so far? Anyone wants me to clarify something perhaps? Okay. Well, trying to get to connect my wallet. Just give me a moment. Let me try to see what happens. If this doesn't work, we might have to use hard hat, because I really want us to deploy this contract. Yeah, hello guys. So hello. So this section is just to complete the part that had failed before we prematurely ended the session, and also to communicate some final things I think I left out. Yeah, MetaMask had failed, but it has finally opened, surprisingly. So to deploy, I'm going to deploy on Flare Custom 2, as you can see, Flare Testnet Custom 2, and I have some testnet CRFLR, C2FLR rather. Now my contract has compiled successfully. That's how I know this green tick mark. And now I want to connect my web address. Oh, it was already connected. So yeah, I am actively on this chain, Flare Testnet Custom 2, and this is my account. This is the account I'm going to use to deploy. When I click deploy now, I should be able to see the progress of the deployment process down here. When I click deploy, it should get me every information I need to know the progress of my deployment. So if you haven't deployed a contract before, when you click this button deploy, it will prompt your wallet to open so you can sign the deployment transaction. When I click confirm, then it should deploy this contract on Flare Coston 2. And it takes a while, but you should be able to see how far it's gone from down here. So right now the deployment is pending, and yeah, well, it's complete. So I can actually view the transaction on a Block Explorer, in this case Block Scout. So it's MetaMask has added a new feature where it verifies the contracts automatically. Verification is simply, I don't know how to say it, but it's a mechanism by which the code itself is tested and converted into a format that you can actually view to see the actual lines of code that were written in a smart contract. Let me open my Explorer and take a look at it. The contract that we just deployed. So you should actually be able to see the contract address and all the information about the contract, including this code as we have it here. But as our Explorer loads rather, we can call the function from down here. So we have two buttons here. One is for the function, the other is for the state variable. So the state variable we have is called BTC USD feed ID down here. So when I click it, it gets me the feed ID. Now when I click this function, since it's a view function, it doesn't run any transactions. Transactions are operations that change the state of the blockchain, but in this case, this one just reads from the blockchain. So I don't have to sign a transaction with my wallet. So when I click it here, it's supposed to return for me the price of Bitcoin. And as you can see, it says this price result has 2 decimals, and this is the price of Bitcoin. So you have to remove 72 and put that dot here. So Bitcoin is approximately 113,000. You can verify that. It's a very fast move because it was about 110,000 when I checked earlier. We can check it out and see if it's actually the price of Bitcoin right now. Okay. Oh, 113,000 for $113,473. 113,000, was it 473? Okay, there's a very steep distinction, but relatively that's the price of Bitcoin right now, and this is the timestamp at which that price data was derived. So now you can see the contract address of the contract that was deployed. It's right here, ends with E28. It should be the exact address that I deployed right here, E28. And since it's verified, I should be able to see the contract code itself when I click on the contract. Was it successful? Did it verify? No, it didn't verify, it failed. But that's okay. So this is a deployed contract, and you can see all the transactions that I've made. So it has only one transaction, a transaction of its deployment. And now from here, you can integrate it with your front end using some of the front end tools that I was talking about. And if you're not familiar with any of those tools, you could still reach out in the forum. It's a very short time, but yeah, we might be able to build something that gives you an introduction to Flare blockchain. And we have a bootcamp coming up starting next week. So if you are interested in continuing to build on Flare, please join in. We'll put the registration form in the forum, so you'll be able to register for the bootcamp. And also, I think I forgot to talk about this. There's a bounty on the Nile Hackathon for building on Flare. $100. It hasn't been put on the site, on the official site, but I'm going to put everything in the forum still. So make sure you check the forum, the Nile Hackathon forum, and you'll find everything there. Okay, I just wanted to demonstrate that, how to deploy a smart contract, and I hope that will be helpful. So yeah, Wish you luck, and I hope you win the bounty.